This time we're going to solve another rational inequality. This one is a little more complicated than the one we solved last time. The one we're going to solve today is this one. 4x plus 5 divided by x plus 2 is greater than or equal to 3. Now the first thing we have to do in this is to get 0 on the right hand side. That is, we've got to move the 3 over. So in this case we'll subtract 3 from both sides. So we have 4x plus 5 over x plus 2 minus 3 is greater than or equal to 0. Now what we'd like to do is have one fraction. So we're going to have to combine these two. In order to do that, we need common denominator. So this 3 has an implied denominator of 1. The least common denominator is x plus 2, so I'm going to have to multiply this fraction, top and bottom, by the x plus 2. So what I'm going to have is this, 4x plus 5 over x plus 2 minus the 3 over 1 times the x plus 2. As we said before, the denominator is missing the x plus 2, so I've got to multiply that denominator by x plus 2. But that means I've also got to multiply the top by x plus 2. So what we're going to have now, I'm just going to speed this up just a little bit. The 4x plus 5 I'm going to distribute this minus 3. So minus 3 times x is minus 3x. Minus 3 times positive 2 is minus 6. So now I have one fraction. And of course, I'm going to combine terms to simplify. 4x minus 3x is x. 5 minus 6 is minus 1. So the numerator simplifies down to just x minus 1. The denominator is x plus 2. So this is my inequality that I wind up solving. In order to solve this, what I'm going to do, as before, is I'm going to set the denominator equal to 0 to find all my vertical asymptotes of the graph. I'm going to set the numerator equal to 0 to find all my x-intercepts of the graph. Another way to look at this would be, what I'm going to do is look at, when I plug a number in here for x, I'm going to get a quantity for the numerator, I'm going to get a quantity for the denominator. Now, whatever that quantity is, if it turns out to be a positive quantity, it's going to be in the solution set. If it turns out to be a negative quantity, it's not going to be in the solution set. And I'm going to determine that by looking at the x-axis. So, as we said, x minus 1 equals 0, x plus 2 equals 0. So, x equals 1, x equals negative 2. So I'm going to do as before. I'm going to draw my x-axis, because that x's represent solutions from negative infinity to infinity, of course. Negative 2 and 1. And I'm building a fence again to show that I'm partitioning the x-axis into these three pieces. As we know before now, the top equation, the inequality that we had, this one, is actually equivalent to this inequality. So, by solving this one, I'm also solving that one. Alright, so we know, of course, that in this case, the x plus 2 means negative 2 is not going to be a solution, because it would make the denominator 0. So whatever I get from my solution, negative 2 cannot be included. Alright, so I'm going to test each piece as before. Choose maybe negative 3 from here and plug it in. So negative 3 minus 1 over negative 3 plus 2 greater than or equal to 0. That gives me negative 4 over negative 1, and that's going to give me 4 is greater than or equal to 0. That's a true statement. So I've already found some of my solutions, but I've got to test the others to see if another piece will contain a solution. So the next number I'm going to choose is in the next piece of the x-axis. I choose 0. So plugging 0 in now. 0 minus 1 over 0 plus 2 greater than or equal to 0. Negative 1 over 2 greater than or equal to 0. That's negative 1/2. Greater than or equal to 0. That's false. So this does not contain any solutions. Finally, I'm going to test a number in this piece, say 2. So plugging 2 in. 2 minus 1 over 2 plus 2 greater than or equal to 0. 2 minus 1 is 1. 2 plus 2 is 4. 1/4 greater than or equal to 0. That's also a true statement. That tells me this piece of the x-axis contains solutions as well. So my final answer now, my solution to it is going to be the piece of the x-axis between negative infinity and negative 2. Notice that in this one's greater than or equal to, so I am going to include, I'm not going to include the negative 2 for sure, because it would make the denominator 0. Also, another piece of the x-axis that contains solutions would be from 1 to infinity, and what I was about to say, I am going to include the 1, not going to include infinity. So, the solutions from negative infinity to negative 2 exclusive, also from 1 to infinity including the positive 1.